We should probably talk about what a function is. It's very helpful to know what a function is. And so we're going to get a little bit into a definition of a function. A function is just a rule that relates every input value to one and only one output value. So our first example, we're going to look to determine which equations are in fact functions. So looking at these, we have part A is y is equal to 3x plus 6. So looking at that, for every input, if x is my input, there's only going to be one output, my y value. So for every x, there's only one y, so this is a function. Now, if y is my input, then we have to do some changing around. So usually in this kind of case, we let x be the input and y be the output. Just because the way it's written doesn't always have to be that case. Let's look at p to the 5t. Again, if we think of t as my input and p as my output, for every t, I'm going to only get one output. So this is, in fact, again, a function. In C, we have x squared plus y squared equals 16. In this case, if I put an x value in, then to get the y value, I'm going to take some square roots to get that figured out. So for every x, there might be more than one y. And for that matter, for every y, there may be more than one x, if y is my input and x is my output. So this one is not a function, since no matter what you put as the input, you're going to get multiple things for the output. On this one, d is equal to negative 4t plus 3. In this case, for every input of, let's say, t, I'm only going to get one d back out. For every input of d, I'm only going to get one t back out. So this also is a function. Letter E, d is equal to 1/2 to the t. Again, for every input, I'm only going to have, if my input is t, I'm only going to get one output of a d value. So if 1/2 to 5 is different than 1/2 to 7, and it's only going to give me one exact answer back out. So this is, in fact, a function. Now we have x plus y squared equals 16. For every x, I would actually get multiple y's because I'd take a square root, which gives me a plus and minus going on, in which case for every x, I'd get two different y's. So this is not a function if x is my input and y is my output. If, however, y is my input and x is my output, then there would in fact be a function. But normally x is the input and y is the output, though it doesn't have to be. Just in this case, we're going to go with that y is my output. So not a function since if, let's just say, if y is the output. So now we're going to get into some thoughts behind some functions. We have something called function notation. This is just a function name, can be anything you want it to be. However, it is useful to make the name something that makes sense and easy to write. So usually it's easier to write the function as one letter, and that letter represents the output. It is also useful to use a name that tells the reader what the input variable was. Notice on that last one, we weren't sure what the input and output was. And so it's useful to kind of know what's the input value and what's the output value is at the same time. Names such as f of x, and it's written as f of x, not multiplication. This does not mean multiplication. It just means f of the variable x or p of the variable t are examples of names. The name of f of x means that the output is f and the input is x. The name P of t is usually used for size of a population at a time t. The best thing to do is to state what the letter stands for so your reader knows what each letter stands for in the context of the problem. We're also going to get into this concept called a domain and range. The domain is the set of input values is known as the domain, and the set of output values is known as the range. So the domain is a set of numbers that can mathematically be inputted into a function. As an example, for the function y equals 7 over x minus 2, 1 can't have 0 in the denominator. So the domain would be every number except whatever number would make the denominator 0, which in this case would be 2. As another example, consider y equals the square root of x minus 5. One cannot take the square root of a negative number and get a real number back out. So the domain would need to be that every number greater than or equal to 5. Many of the functions that we deal with in this course or Math 142 have no restrictions on what numbers can be inputted into the function. As an example, y equals 5x plus 7 can have any number put into x. The domain of this function is all real numbers. In some functions, the large domain is not practical for the context. As an example, the function p equals 5 times 2 to the t has a domain of all real numbers, but if t represents time and p represents the size of the population, then t can't be all real numbers since you can't have negative time. This means the domain is from 0 on up. This is also known as the practical domain. As another example, if h is equal to negative 16t squared plus 3t plus 1, and h represents the height of a ball and t represents time, the domain of the function would be all real numbers. However, it doesn't make sense for time to be negative, and it doesn't make sense for time to continue after the ball has hit the ground. So the domain is from 0 to when the ball actually hits the ground. Again, this is known as the practical domain. The range is a set of numbers that can be answered to when the domain values are inputted into a function. As an example, for the function y equals 7 over x minus 2, one cannot ever get 0 out of this function. This is because no matter what number is inputted in for x, there's no way to get 0 out of this function. Try a few numbers to prove this to yourself. So the range is every number except 0. For the function y equals the square root of x minus 5, the numbers you can get is 0 or a positive number. There's no way to take a square root of a number and get a negative number as the answer. So the range of this function would be all numbers greater than or equal to 0. Just as there's a practical domain, there are practical ranges. The practical range depends on the practical domain. There are many different functions. Functions called linear or exponential are used in growth and decay, modeling, and financial situations, but there are many other functions that exist. We're going to talk about some visualizations also. Many times it's useful to look at the function using a visualization. This can be for the data or for the function expression. The visualization is known as a graph, and technology can be used to visualize the function. Example number 2, we're going to use technology to graph the following function, y equals 2x plus 6. We're going to do this using Desmos. So I'm going to come over here to Desmos, and I'm going to type in y is equal to, I already forgot my equation, 2x plus 6. So here is my graph. I can see a lot of it. If you don't notice, I just typed y equals 2x plus 6. I don't really like the red line, so if you want to change the line, you can click and hold, and you can pick different colors. So if you like blue instead, you can get a blue line. If you don't want to show the line, you can just click it and it will unshow it. Show it, click it again, it will show it. I can see a lot of this graph and see what's going on, but if you want to see a little bit more, you can actually change the domain here by clicking on the little wrench, and then you can look and see, oh, I can change my domain, I can also change my range. So my x-axis is my domain, my y-axis is my range. So if you want to see a little bit more, it looks like my x-axis might be long enough, but maybe I want to go up a little bit higher on the y-axis. So maybe I want to go up to, I don't know, let's say 12. And notice it just automatically changes the window for that new thing. So you just see a little bit more of the graph. You didn't need to do this. And if you want to go back to the standard viewpoint, you can actually hit this little helm and it puts it back to the standard viewpoint. You can also hit the plus that will zoom in and the minus will zoom out. So that's using Desmos. We can also use the TI-83 or 84. So if you want to use the TI-83 or 84 to do that, here's what it looks like. We're going to hit clear. You always get that when you turn it on. This top row here is where all of the graphing is done. We're going to click on Y equals. That will give me all the different Y's I can work through. Again, I want to do 2x, so I'm going to type in 2. Now, there's an X here above one of the keys, and I can hit the big alpha button to get that. But it knows you're going to use X a lot, so it actually put a little X button right here. So we can actually just click here. It says X, T, theta, N, because if you happen to use different variables, different types of functions, you can do that. But if you click it, you'll get an X when you're in function mode, which is pretty much the mode you're going to be in. Plus 6. So I've now imported my function into here. I can now just hit graph, and it will graph that function up. Again, if I need a little bit more detail on this and I want to see a little bit more, I can change this. I can either zoom and I can zoom in or out. So let's go zoom out. Keep hitting, oops, didn't do that. I can do that again. I can do zoom out again. And you can keep zooming in and out if you want to. I can also go and change my window. This is known as the standard window, where the x goes between -10 and 10, and the y goes between -10 and 10. The x scale and the y scale just says how often you're going to see a tick mark. You don't really care what the rest of these things say. This is your resolution of your screen, and this is for tracing and so forth. So if you want to change this, and let's say I want to go, I like my x is fine, but I want to see a little bit more upper y, I can type in 12 for this, hit graph, and now it's changed my window to include that. I can also, like I said, zoom in and out, and there's other things I can also do with this, but we're going to do those later. So now we're going to do another graph. We're going to do P of t equals 5 to the t. So I'm going to first go do this in Desmos. I don't want to graph this line. I can leave it there. I can leave this all I want and have it there. I can turn it off so it doesn't actually graph right now. And I can actually, in Desmo, type P of t. I don't actually have to use X's and Y's. I can use whatever letters I want. I can say P of t is equal to 5. Now, I do need to do a power. You can do the power several different ways. You can use the up arrow, the caret, which is above the number 6, and it'll automatically put into a power, and that way you can get your T. I can also, if you don't like doing that, there is this little keypad down here, and you're going to notice that there's different choices you can have down here. You can get your X's and Y's this way also. You can do squared, and this is the same on the calculator as it is on the computer. And then I can see I can get a square if I just want a square. I can also get an a to the b. So now if I type a to the b, it'll then also put it in the exponent. So either way is fine. If you're on the computer, you don't have, I'm sorry, if you're on the phone, you don't have the caret, so you'd have to use the keypad here. And there's my graph for that. Again, I can change my window if I need to see more of the graph. If you want to turn the other one on, you can turn that one back on, and you can now see both graphs at the same time. If you want them to be different colors, you can then pick a different color. Let's say I pick black for that one. And then you can change your window if you want to see where they intersect. So there's different things you can do with this. On the graphing calculator, again, everything is typed into y equal. And I can leave this one here. If you don't want the plot, you can move over all the way over here and you can actually hit enter and it will change the type of plots you have. You can change it to a different color. If you don't want it to be blue, you can be red or black, magenta, green, orange, brown, navy, all these different colors you have to choose from. And you have more colors in Desmos also. If you don't want it to be line, you can actually come down here and change it to shading, just a dot, just a line with a dot, or just dotted and more dotted and back to your line. So you can do different things. We can say clear. I don't want to do that anymore. So we'll go down and we'll hit that. If you don't want to actually have it on, you can actually come to the equal sign and hit enter, and it will now turn that one off. So it doesn't plot at the same time, but you don't actually have to delete it. Now I want to do 5 to the T. The caret is how you do powers on the calculator. So we're going to use this caret. It gives me a power. Notice it gives me a little power there. If this is for the T84, if you have a T83, you might have an older operating system, so it may not look exactly the same as this, but it is something that you can use. It does very similar things. Um, I know we use T, but the calculator only uses Y and X. So if I click on this, even though it has a T on there, if I click on this, I'm only going to get an X. Yes, there is a T somewhere in here. You can find a T in your characters, but you don't want to use that T because the calculator only uses Y and X when we're plotting. Then arrow over to come down out of there, and then you're out of that. Then I can hit graph. Oh, I should mention that with zoom, you can also do zoom. If you've changed things around, you can actually do different zooms and you can do a zoom, different zooms that you can actually work with. Zoom fit means you can set your X's to what you want, and then it'll fit your Y for those. The zoom in and out, zoom box. Um, there used to be just a zoom standard. Oh, there it is. Zoom standard is number 6. So if you did change the window and you want to come back to that standard window of -10 to 10 and -10 to 10, you can just come here and hit enter and it'll give you the standard window. Notice it did a nice red line. If you come to Y, you can change that color again just by arrowing over and changing that. If you want both plotted at the same time, just go to that equal sign that was turned off, hit enter, it will now turn it off, and now you can graph both at the same time. Intercepts, notice that both graphs cross the vertical axis. That point where the graph crosses the vertical axis is called the vertical intercept. The vertical intercept is found by allowing the input to be 0. If using X and Y for the variables, the vertical intercept is also called the y-intercept since it crosses the y-axis. Some graphs cross the horizontal axis. The point where the graph crosses the horizontal axis is called the horizontal intercept. It is found by letting the input value be 0. If using X and Y for the variables, then the horizontal intercept is also called the x-intercept since it crosses the x-axis. Finding the intercepts is sometimes difficult. An easy way is to use technology to find these, and so we're going to do it that way. So find the vertical and horizontal intercept using technology for y equals 2x plus 6. Using Desmos, we're going to find the horizontal and vertical intercept. So we're going to do those first on Desmos. I happen to have that graph still in here. I don't want this other one plotted right now, so I just want to see that graph, so I'll turn that one off. I see that we intersect the vertical axis right here. And I can actually click on that point and it will tell me exactly what that point is. It tells me that point is 0, 6. I can come over here. I can see I cross the horizontal intercept at this point. I can click on it. It tells me that point is -3, 0. I can get both at the same time by just clicking on them. There are my 2 intercepts. So finding the intercepts on Desmos are really, really easy. And if you want to do it for the 5T one, you can turn this one off, turn this one back on. Notice this one does not actually cross the horizontal axis, so it has no horizontal intercepts, but it does cross the vertical intercept right here. And again, I can click on it and find out what that value is. On the TI-83 or 84, it's a little bit more work. First up, I only want to do the one, so we're going to turn the other one off. So I'm going to come down here and turn it off by hitting enter. Now here's my graph. I can see I have 2 points. I have this one right here and this one. This is where it crosses the vertical axis. I've got a horizontal intercept right here where it crosses that. To find these is a little bit more work on these calculators. It's not as easy as just hit the button, hit the points on the Desmos. So the first thing I'm going to do is I'm going to go into calculate. So second trace. So I hit the big second button. Anything that's above here in blue is always means I had to hit the second button first. So I hit the second button and the trace button. That gives me the calculators. I'd like to find a value. I'd like to find the value when x is 0. I hit enter, put 0 in, enter, it gives me my 6. So finding the y-intercept is pretty easy, or the vertical intercept is pretty easy because you're just putting 0 in for your input value, your x value. So we have that one right now. Finding the the x-intercept or the horizontal intercept is a little bit more work. So we're going to hit calculate. And we want to know the 0. So we're going to come down to number 2 for the 0. And what it wants to know is it wants to know a left bound. That means we have to kind of arrow over till we're to the left of that point. We can see that point right here. We kind of know what that point is. We think it's 0, 3 because we can kind of see it, but we want to find out what it is exactly. So we just want to arrow so we're to the left of it. Notice my cursor, when I use these left and right arrows, I moved over to the left of that value. If I hit enter, it's now going to ask me for the right bound. So it wants to go to the right of that value. So I'm just going to move using the right arrow, I'm going to move over till I'm just to the right of it. And I'm going to hit enter. And notice it now puts some lines here that says we're going to be between these two values. It asks for a guess, and you actually can just hit enter. You don't need to get any closer to it. If you want to, you can. You don't have to. It will find it without the guess, without you being closer to it. And then it comes back and tells you my 0 is -3 when y is 0. So that's the way to do it on the TI-83. Again, let's just show it for the other one. I'm going to turn this one off. I'm going to come down and turn this one on. I'm going to hit the graph there. Again, this is moving along. I can't see where it crosses the horizontal axis. And in fact, it never crosses the horizontal axis. So it has no horizontal intercepts, but it does have a vertical one. So we can find that one. Again, with that one, you just hit second trace. I just want to evaluate when x is 0. So I just hit, again, number 1, put 0 in for x, and it goes back and tells me y is 1. So that's how we find the x and y intercepts on our calculators and on Desmos.